Saturn appears to the naked eye as a bright yellow point of light in the night sky. Even with the most powerful telescopes, the planet, nearly 1 billion miles from Earth, is too far away to be studied closely. Its satellites appear as no more than tiny point light sources. This picture of Saturn and 3 satellites was taken by the Voyager 1 spacecraft on August 24, 1980, 66 million miles and 80 days away from the spacecraft's closest encounter with the ringed planet. Saturn is the second and final planetary visit for Voyager 1, which will leave the solar system by 1990. In March 1979, the spacecraft swept past Jupiter, and 4 months later, its twin, Voyager 2, made its encounter with the giant planet and the Jovian satellites. By November 12th, when the spacecraft flies past Saturn, scientists will be studying high-resolution pictures of the planet, its distinctive rings, 12 satellites that orbit the planet, and possibly others not visible from Earth. We know that Saturn, like Jupiter, is a cold, gaseous giant made up of abundances of hydrogen and helium. Voyager has already determined that a Saturn day lasts 10 hours, 39 minutes, and 4 seconds. The planet takes 29 Earth years and 4 days to complete a single rotation around the Sun. Although the planet is 815 times larger than Earth, its mass is only 95 times greater. At least 6 rings encircle Saturn. The F ring, observed by the Pioneer spacecraft in 1979, may contain a number of small satellites. Each ring is believed to be composed of chunks of ice and rocky debris, ranging in size from about 100 feet in diameter to tiny specks of dust. Saturn's moons may consist of rock and ice. Some may be solid globes of frozen water. They are a new class of mid-sized satellites at unknown stages of evolution. Titan is the most prominent moon. It is the largest in the solar system and the only satellite known to have an atmosphere. On November 11th, Voyager 1 will make a very close pass of Titan, just 2,500 miles above its cloud-shrouded surface, and photograph its terrain if it is visible. After Voyager passes through Titan's shadow, it will cross below the plane of Saturn's rings. During the next 2 days, it will view Tethys, pass within 100,000 miles of Saturn itself, past Mimas into Saturn's shadow, approaching Enceladus. As the spacecraft pulls out of the shadow, it will photograph Dione and Rhea. 10 science instruments and spacecraft's radio communication system will measure the planet's atmosphere and cloud composition and record radiation emitted from Saturn. The composition of Saturn's atmosphere will be determined by recording the way sunlight and the spacecraft's own radio signals are distorted by the planet. As Voyager passes into Saturn's shadow, the spacecraft will search for lightning and auroras like those found at Jupiter. Emerging after an hour in darkness, Voyager will again probe Saturn's atmosphere as sunlight and radio communications return. As Voyager speeds away from Saturn, the planet's rotation will be recorded in time-lapse photography. The spacecraft may continue to return data as it flies beyond the edge of the solar system, measuring the galactic winds of deep space. Voyager 1 and 2 were launched toward the giant outer planets by NASA in August and September 1977. These intricate automated spacecraft were designed and assembled by the Jet Propulsion Laboratory, which manages NASA's planetary exploration program and controls the Voyager mission from Pasadena, California. Flying a shorter, faster route, Voyager 1 was launched 2 weeks later than its twin and arrived at Jupiter 4 months earlier. In their encounters with the Jovian system last year, the two Voyagers returned more than 33,000 pictures of Jupiter. And the Galilean satellites, volcanic Io, ice-encrusted Europa, Ganymede, the largest satellite, and ancient Callisto, the most heavily cratered body known in our solar system. Both Voyagers, which will return more than 70,000 pictures of the distant planets to Earth, will pass beyond the edge of the solar system by 1990 and fly on into the vastness of interstellar space.